Hello and welcome. My name is Michael Ward, and today I'm going to talk to you about the VRS Maintenance Guidance Handbook. To start, I'm going to give some background on why this document came about. When most people think of safety barriers, they picture just two components, two pieces of steel, a post and a beam, but there's much more to a barrier system than meets the eye, and many things can go wrong if it's not properly maintained. That's why maintenance is just as important to ensure a safety barrier system performs as intended. So what we know is that designers are guided by design standards, installers, contractors are guided by the specification for works or Series 400, whereas when it came to maintenance, there was little to no guidance for maintenance personnel. So what I found out was that there was an inconsistency across the network in terms of repair and replacement. There was lack of knowledge and guidance out there. So what do? We applied knowledge and experience gained from years of work on the TII VRS repair and replacement programs of work, incorporated best international practices, liaised with various stakeholders in the industry, including contractors, designers, suppliers, local authorities, and National Road Office staff. As a result, this document was produced. This document is a national guide for safety barrier maintenance. It offers clear and practical advice on policy decisions. It ensures consistency across the regions. It shares international best practices. It supports newcomers to the industry, and it emphasizes safe maintenance operations. Essentially, this document is a national manual for those managing and maintaining road safety barriers. The structure of the document is shown on the left-hand side. It touches on policies and general requirements, repairs after collisions, planning for VRS maintenance, VRS improvements. It also includes a VRS maintenance flow chart and various appendices. VRS maintenance itself can be considered a combination of all measures carried out to maintain the functionality of a VRS system, and can be divided into the following basic steps, which are maintenance, inspection, repair work, and improvement work. Just a bit about policy and general requirements. Forgiven roadside principles should always be adopted, and the hazard mitigation process should be followed. Can we remove the hazard? Can we relocate the hazard? Can we redesign the hazard? Can we revise the road layout? Can we reduce the impact severity? A barrier should only be provided as a last resort. Any successful VRS maintenance regime can only be achieved if those involved have appropriate training and knowledge. TII operate and maintain a database of VRS assets on the national network. For the non-national network, local authorities are responsible for maintaining VRS assets. Issues relating to existing VRS can be highlighted by a variety of stakeholders and should be subject to a VRS inspection. CE certs are key to managing the certification and functionality of a VRS. This ensures relevant documentation is at hand, including system drawings and installation manuals. Health and safety. All personnel involved in the maintenance of VRS should seek to maintain safe working practices at all times. A typical process after a VRS collision consists of reporting of the damage, making it safe, inspecting the damage, prioritizing repairs, the repair work, and recording and certifying of the works. Reports of damage can come from a variety of sources. Issues on the national network should be picked up by the VRS maintenance contractors. Any issues identified may also be uploaded to the TII VRS defect portal. There are two scenarios to consider making safe a damaged VRS. The first is where a VRS is impacted but can still perform. This is where minor damage has occurred and debris should be cleared until a full assessment is carried out. The second scenario is where a VRS is impacted and has suffered major damage. This is where the VRS is beyond functionality following a collision. The area should be made safe by removing debris. Any exposed ends should be treated to avoid spearing. The use of temporary barriers and traffic management should be considered. Safety inspections may be required in response as a result of a collision. Once a safety inspection form is completed and submitted with recommendations, it shall be subject to an employer instructed work order. As all budgets are limited, how do we prioritise a repair? Repairs can be broken into high, medium, low categories. A high priority repair can be classed as where beam sections are no longer continuous, there are broken or separated lap joints, 3 or more posts have been damaged, the deflection of the beam is greater than 450 mm. A medium priority repair can be classed as where beam sections are continuous, lap joints are not separated, 2 or fewer posts have been damaged, and the deflection of the beam is less than 300 mm. A low priority repair can be classed as where beam sections are continuous, lap joints have not separated, no posts are damaged, and the deflection of the beam is less than 150 mm. Just some repair and rule of thumbs to consider. Terminals and transitions should be replaced with tested and TII approved terminals. Where a terminal is being replaced, a gradual system progression should be provided to the original safety barrier. Torque and tension should be checked to ensure that they are within the range of the limits specified in the installation manual. No drilling or cutting of beams is permitted on site to accommodate on-site repairs. This should be prefabricated off-site. Where driven posts have moved less than 300 mm and not suffered any damage, they can be reused. All post driving rigs should be fitted with the correct driving rig attachment. Where a post is in a concrete foundation that has been damaged, both the post and the foundation should be replaced. Ground testing for repairs should be carried out in accordance with Series 400 specification for road restraint systems. So how do we know when we should replace or repair a VRS? As a general rule of thumb, if more than 50% of the barrier is damaged or is out of spec, the entire length of the barrier should be replaced. The typical process for planning for VRS maintenance consists of the planned inspections, data processing, prioritizing interventions, carrying out interventions, and recording and certifying the works. Planned inspections can be done via safety patrols, which are drive-by patrols conducted in slow-moving vehicles. These patrols identify new defects or damage on the network. This is done monthly on motorways, dual carriageways, and national roads, and biannually on national secondary and other roads. Detailed inspections may also be undertaken and are carried out less frequent than safety patrols. They are designed to compile VRS inventories, detect any VRS defects, and record VRS which may be non-compliant with the current design standards. They should be carried out on foot using a comprehensive inspection checklist. Detailed inspections should be undertaken every 5 years for steel systems less than 10 years old and for concrete barriers less than 15 years old, and every 2 years after 10 years old for steel systems and 15 years for concrete systems. The required lifespan for steel systems, terminals and crash cushions is not less than 20 years. For concrete barriers is not less than 50 years, and for timber-clad and temporary safety barriers is not less than 10 years. There are a number of different procurement options available. On the national network, MARC contractors are contracted to carry out VRS maintenance services and inspections. Similar to the MARC, on the non-managed network, special VRS contractors have been allocated to a region to maintain the network. Local authorities can use their own public procurement procedure to appoint a VRS contractor. If improvement is needed, what design considerations should we take into account? A site visit and a risk assessment is required. Can forgiven roadside principles be adopted? If the proposed design does not comply with standards, are departures required? Designers should supply contractors with a detailed schedule of the works. Design input is required for all barrier replacements. Any design changes should not be carried out on site without prior approval from the designer. VRS posts should never be driven into a filter drain. Post centers may be adjusted to avoid objects such as chambers, but done so in accordance with the installation manual. Post sockets should be considered in all new concrete foundations or in locations of high attrition or high risk. Surface mounted posts should only be used where the system has been tested and CE marked for use. Verge ground profiling should be undertaken prior to VRS repair works. Reinstatement should match the existing verge and should be free from large rocks, boulders, and be maintainable. This document also contains a useful VRS maintenance flowchart which outlines the various maintenance procedures to be followed. Finally, just to note that this document is a guidance document. As the industry continues to evolve, it is expected that this document will be updated periodically to reflect any new developments. Thank you for listening.